This is Algebra 2B, Probability Lesson 7, Permutations and Probability. Okay, counting principle. So we know how to count, like 1, 2, 3, 4, hopefully. But let's say we want to count something really, really, really big. And we're looking at the number of ways to do this versus the number of ways to do that versus the number of ways to do the next and the next and the next. The counting principle is, if you want to count something really, really big like that, you take the number of ways to do the first thing times the number of ways to do the second thing times the number of ways to do the third thing, and so on and so on and so on. And that will be the number of ways to do all the different possibilities. Okay, that's our counting principle. So if we're looking at factorial, factorial is a special symbol that you might want to call exclamation point. To do a factorial, we're going to start with the given number, and then we are going to apply the counting principle. We're going to multiply, but we're going to multiply by one lower than that number, and then we're going to multiply by one lower than that number, and we're going to keep going all the way until we reach 1. Okay? I'm going to add some parentheses here to show that that's 1 less than n, that's 2 less than n, and so on and so on and so on. So as an example, 4 factorial would be 4 times 3 times 2 times 1. You could do something crazy like 30 factorial. That would be 30 times 29 times 28. And I'm going to go dot, 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 because we go all the way to 1. And then times them all together. Permutation is when we're trying to arrange items. And we're trying to pick things like this goes first, this goes second, this goes third, this goes fourth, okay? And there's a formula for it, but I don't really like the formula too much because I feel like it's kind of confusing. But it's n factorial divided by n minus r factorial. And what you're trying to do is arrange n things, but only using r of them. We'll go of them. Does that fit? Arrange n things using r of them. So that sounds kind of weird, but what I mean is, let's say I have 10 things and I want to arrange 3 of them. Okay? The formula is 10 factorial divided by 7 factorial. Okay? So that's going to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 on the top, and 7, 6, 5, 4, 3, 2, 1 on the bottom. 10, 9, 8, dot, 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 all the way to 1. And then in the denominator, 7, 6, dot, 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 all the way to 1. So what you're supposed to recognize is that numerator, denominator, they cancel out. So the 7 through 1 in the numerator cancels out with the 7 through 1 in the denominator, and you are left with just 10 times 9 times 8. Okay, so here's how I like to approach it instead of using the formula. The n is our starting number. We started with 10. The r is how many blanks we have to fill out. So we have 1, 2, 3 blanks. And then we apply the counting principle, we multiply, and we always, always, always count down. Okay? So that looks like 720. Just to give you another example, let's say I did 6p2. That's going to be 6 times 5. I start at 6, I have 2 numbers, I times them together. And one more, how about 12p4? That would be 12 times 11 times 10 times 9. Again, we start at 12, and then we have 4 numbers, and we always count down, and that would be 11,880. And then I'm going to stick this at the top. If you ever have NPN, that's the same as n factorial, okay? Right, if you look right here, 4 factorial. 4 factorial was start at 4, count down 4 numbers. That's 4p4. Okay? So factorial is really just a permutation where you're going all the way and using all the numbers. So that's a lot. That's usually pretty confusing. Let's give some of these formulas a try. Example A. Suppose a licensed plate has 3 letters followed by 3 numbers. How many license plates are possible? So we're going to use the counting principle here. We're going to say how many possibilities, how many possibilities, how many possibilities, times them all together. Okay? So our license plate can have any 3 letters. Letter, letter, letter. Any 3 numbers. Number, number, number. Then we're going to say how many possibilities for each place. Okay? So any letter means you can pick a letter A through Z. And if you counted the letters in the alphabet, there are 26. Again, any letter. A through Z, there are 26 possibilities. Another letter, another 26 possibilities. Okay? Next, we need number, number, number. If we count the digits 0 through 9, don't be tempted to say 9. There are 10 of them. Don't forget to count 0. 1 through 9 plus another for 0 makes 10 digits. Another 0 through 9 is another 10. Another 0 through 9 is another 10. So there are 26 options, 26 options, 26 options, 10 options, 10 options, 10 options. If we times all those together, apply our counting principle, that will tell us that there are 1, 7, 5, 7, 6, 0, 0, 0, 17,576,000 license plates that fit this scheme. Okay? What is the probability that the license plate has no repeated letters or numbers? So here I said there were 26 possibilities A through Z. If you are not allowed to repeat, you no longer have 26 options. Doesn't matter what letter you picked. You picked B, there's only 25 left. You pick J, there's only 25 left. You pick any letter of the alphabet, there's only 25 left. And this is what that permutation is. Once you've used something up, you can't use it again. We have to start counting down. Okay? Again, you pick another letter. Now there's only 24 left. Okay? So this right now is technically 26p3. We started with 26 letters. We arranged 3 of them, 26 times 25 times 24. Now let's look at the numbers. We're starting at 10, because I can pick any one of my numbers 0 through 9. Once I've placed one, though, I no longer have 10 left. I only have 9 left. Once I've placed another, for my third, I only have 8 left. So now we have 10p3. We started with 10. We arranged 3 of them, 10, 9, 8, and we're going to times everything together. And that will tell us how many license plates do not allow for repeating characters. So 26, 25, 24, 10, 9, 8. Looks like 1, 1, 2, 3, 2, 0, 0, 0. 11,232,000 of our 17,576,000 license plate do not have repeats. Okay, letter B. 7 flute players are performing in an ensemble. How many possible arrangements are there for the players' names in the program? We have 7 players, and we want to use all 7 of them. So this is 7p7, also known as 7 factorial. We have 7, 6, 5, 4, 3, 2, 1 ways to arrange those people. Looks like 5,040. If the names of all 7 players are listed in a random order, what is the probability that the names are in alphabetical order? So alphabetical order would be like A, B, C, D, E, F, G, right? Let's just pretend everyone started with those letters to make it easy, right? A, B, C, D, E, F, G. Now, what we figured out in letter A is that there's 5,040 ways to arrange these letters. Like you could go B, A, C, D, G, F, E. And then you could go like E, D, C, G, B, A, F. Sure. If I kept going and every single way there was to do this, there's that many of them. But guess how many of them are A, B, C, D, E, F, G? Only one. Out of all the different ways to arrange those letters, only one of those ways is the alphabetical way. So 1 out of 5,040 are alphabetical. The other 5,039 ways would be a scramble, right? Letter C, Jean-Pierre has a solo and would like his name listed first. What is the probability that he will be first? So if we have 7 spaces to list, but space 1 has already been taken by Jean-Pierre, so that gives us 6 people to put in the remaining 6 places, also known as 6 factorial. So that will be 6, 5, 4, 3, 2, 1. 720. So using these letters that I wrote out again, let's pretend that Jean-Pierre was A, right? So there's going to be 720 permutations, A, D, C, B, E, F, G. A, B, G, F, E, D, C. If I kept going, right? There's exactly 720 of them that are going to start with A, and all the rest of them start with anything else. So the probability he's first is 720 out of 50, 40. And last one, how many possible seating arrangements are there if a bench can only sit 4 people? So we have 7 people, but only 4 of them are going to be able to sit down. We have 7, and we need to put 4 of them down, okay? So that would be starting at 7. But filling out 1, 2, 3, 4 spaces, but we always count down, because if we have 7 people for the first option, but somebody sat down, now there's only 6 people for the second spot, and then someone else sat down. So now there's only 5 people, someone else sat down, so now we have 4 people. So we filled out our 4 spaces, counting down, and then that is 7 times 6 times 5 times 4. There are 840 ways for 4 people from a group of 7 to arrange themselves. That is it for this one. Good luck on the exercises, and let me know when you have questions.